Read out this first one, make sure your neighbor was able to do it. After that, we're gonna do some problems from page 14. These guys right here. On page 14. Getting understands and use okay. A couple are pretty tough, I know.
Oh.
Like the.
Oh, like the staff thing,
Like this thing.
Yeah.
You get it.
like this.
Yeah.
Yeah, like
Here.
anything that you just like,
See, it's
then you-
better now.
like for egg.
You did it immediately. I thought you were doing like. Because
Oh,
here.
yeah. Same.
Same situation. See, you can't do that. You do it immediately. Yeah.
They're going okay?
See, you take out an X from the one, so you get X squared minus. And then one of the factors on the top is also X squared.
So then, like what I'm saying, like,
Oh,
on the top, we take out X squared.
Yeah.
Like it's just X squared. Three.
yeah, and then minus 4.
X equals
Oh.
3X minus.
What? Three. Yeah, but then you can't, sorry, you change it. Maybe I actually know. See, that's like-
Oh, wait, you don't have.
I don't think it's like just figure out like X is where you just have to get your four.
It's like you just plug in, okay, that was like for you plug in 3,
Oh, yeah,
and
yeah,
then like,
it's like-
we kind of, yeah.
But I don't think you can. I mean, like,
Sorry.
maybe you can group them because if you're not. So that's not, yeah, like,
Yeah, so what happens? Well, but
Right here.
You factor these two, no?
Since these aren't the same.
Would you factor this up?
So you
like that wouldn't,
normally you factor.
I know what
okay,
you.
no, it would work, because then, like, for the bottom, it would just be that. So then like, plug
Yeah,
in
okay.
2 for the bottom, and then that. So
Yeah.
you just be
No,
left.
it's still zero.
Well, no, but then you cancel the.
I know, but I'm saying why.
Oh, yeah, you're right.
Like, I don't think, because these are still two separate terms and because.
No, because it's like.
No, 30 seconds.
Oh,
I
I
don't
see.
Oh,
Like, maybe you can, but I think they really do.
I think you're, then if anything, then. if one of them is not-
Okay, we ready? Ready or not? Let's see what you got. I have a question for you. Do you always need to factor when you're solving these kind of limits with a rational expression? No, only when what happens? Right, when you plug in that number and you get 0 over 0. So if you plug it in and you get something else, then you have to change up your strategy. And sometimes you just get a number. And if you get a number, then that's your answer. You don't have to do anything crazy. So you notice in this first one, now maybe you'd even try, but if you plug in that -1, do you get 0 over 0? So you get 1 minus 4 plus 3. I do believe that's 0. So 1 plus 1, yeah, I've got 0 over 0. Oh my gosh. So I need some help with this one. Kimmy, can you help me out, please? Okay.
-1.
And then you get what? Do we agree -2/3? Are we good? So do you see how like canceling those factors kind of remove the issue? Like if you were to plug that -1 into both of those factors, that'd be a problem. Kimmy, thank you. That was fantastic. Okay. Nico, which one of these three would you like to do? See, okay. Nice.
Alright, so first I factored out the x squared in the first two terms on the top.
Okay.
So it's squared times x plus 3.
Uh-huh.
Factored out the square y, factored out 4 from the last two terms.
+4 and -4. Okay.
Minus 3x minus 1.
Okay.
All of it. X times x squared minus 1.
And maybe you could have just immediately made that this, right? The bottom kind of rolls out. Now, what do you think about that top? X squared minus 4 times x plus 3 times x minus 1. Is that what you're saying? Oh, 3x minus 1. Okay, 3x minus 1. Okay, and if we were to multiply all that out, would we get x cubed?
No.
Oh, no.
Something went wrong. You did a great job separating it. It's 4 terms, so how do you factor that? You break it up into 2 and 2. You got your common factor of each. So where did we go wrong here? Or does this method just not work? Did you just break math? Is that what just happened? We just give up factoring by grouping. Well, for factoring by grouping to work, this has to be the same as this. So, although it seems like a perfect candidate for factoring by grouping, it's not. Even though the 12 and the 4, they're frustratingly off, aren't they? If they were flipped, it'd be over. It'd be fine. So, it doesn't work. Do you want to try a different one? Or okay, so you were struggling with that one, and then. Well, thank you for giving me the old heave-ho. Appreciate it. Levi, which of these would you like to do? E or G? Okay.
And multiply top and because it was zero over zero, I multiply top and bottom by the conjugate, so root x plus 2.
Conjugate of the denominator. Okay.
So then on the bottom, I just left the unsimplified is x minus 4 times root x plus 0.
Okay. X plus 2, I think is what you mean.
Then on the bottom, I simplified that to x minus 4.
Okay.
X minus 4 is canceled. And then you can plug in 4 and get 2.
2
So it's 4. no.
plus 2 is 4. Is that clear? So do you see how when factoring works, right? When you get that 0 over 0 and when factoring works, the thing that you cancel is kind of the troublemaker, isn't it? Like x going to 4 makes both of those factors 0 in that case. Or up here, x going to -1 makes both of those factors 0. Those are the troublemakers. That 0 over 0 behavior is gone. Who'd like to talk about, before we do C, who'd like to tell us what they did for E? Yes, Ellie.
Treated the Y's like you. I don't know if that's right, but so then I said y plus 8 over y minus 8 times y plus 8,
Okay.
and then I canceled out the y plus 8 to get 1 over y plus 8.
Okay.
So then I get 1 over 0 to
Yeah, this one didn't remove that trouble, did it? And also it didn't start with 0 over 0, so not x, I should be saying y. Now, when you said you treated it as x, I'm not sure what you mean by that. Do you want to? Okay. Did anyone else do that? Like you can see, I'm writing x all over the place. And when the variable changes to something else, it's a little weird, especially when it changes to I, which sometimes happens, and I don't know why people do that. But it could be a variable. It's too confusing once you get to algebra 2, though. Yeah, it's weird to use different variables, but y is fine as a variable. So we do agree that 1 over 0 is undefined, but is this asking for f of 8? I'm not quite asking for that. I want you, if you haven't already, discuss this specific issue with your neighbors, or maybe in a group of 4 or 3 or 4 around you. What's going on here?
yeah, so
Oh.
I think it's
Yes.
I'm all out of ideas.
It's like all Y tools.
Yeah,
I got
exactly.
this, and then
Maybe like
I do it.
Yeah.
Yeah, it was the circle when it grew.
It comes only from the right, so it could be something else on the side, that's why it like makes it hard to. Like, decide it out of your phone.
It looks like it's approaching.
Okay,
It would be a
so you've had some time to discuss. Who'd like to tell us what they were thinking for this one? Yes, Sahana.
Well, we were just talking about how like it's hard to know exactly what the limit is because it's asking you to see what the limit is from the right side since it has the like the plus.
Mhm.
So it could be like something else from the coming from the left side. So that's what it's.
It's hard to tell. Okay, so maybe, should we say the answer is unclear? Should we just say that? Maybe. It's nice for there to be an answer, and maybe sometimes the answer is does not exist or not enough information, perhaps, or something like that. Hard to tell. Yeah, Levi, what do you think?
So what do you mean by it's unclear if it's going to be left? Like, it isn't a plus, it's automatically it's going to be the right or above it.
Oh.
You can't just calculate the like limit because the limit is like the limit of just like the number not coming from either side. It's like the limit could be different if you look at it from the positive side. It could be something else if you look at it.
So you're saying like, even though we know it's coming from the positive side, we don't know how to isolate.
Yeah, exactly.
Are we good with that? Any questions? Yeah, Kimmy? I love it. What would you do with the calculator?
So we're down to, yeah.
So 9, like 8.9, 8.85, like that kind of slow. What's that? Like 8.001, 8.0001. Yeah, what would happen if you plug in those numbers? Oh, but it's just a number. It says that y, the unknown, is going to 8 from the right, so y could be a number like 8.01 or 0.0001, 8.001.
Yeah.
But is that okay to do? We're dealing with y, is it okay to do that?
Oh.
Yeah, y isn't always an output, unless it's y equals a function of x. Y is just a variable, that's fine. Yes, do you have some, Brianna? Yeah.
Well, I was gonna say something like, oh, like, can you give a range, but I just realized that it's gonna be like either really big or like really small, so there's not, it's gonna be like endless, because you need to go on 0.0.
So you say that there is an
Yeah,
answer?
well, I was saying like, if you're coming from like the top, is it,
Tom?
or whatever, from the right hand side, from the right,
Mhm.
like y or whatever, as you're approaching the limit, isn't y always gonna be greater? Or am I?
Well,
is that-
I think some of what's happening is we're so used to this being y and this being x that maybe there's some confusion there. But y is just a variable here in a function of y. So we're just plugging in, like Kimmy was saying, plug in values close to 8 on the right. And like you were saying too.
Is it the number that, like, as we're approaching at that 8 from the right, isn't that number always gonna be bigger than 8?
Yeah, exactly.
Give like a range. It would just be like, can't find.
We cannot define it. That's why we say that the answer is infinity. It's going to get bigger and bigger and bigger. The closer we get, the higher that number is going to get. Does that make sense? And Kimmy, I think that's exactly where you were going. Is that what you were saying? I wouldn't even, well, you could use your calculator, but I think we don't need a calculator. Like I could do this in my, this is 1/10,000. 1 divided by 1/10,000, it's 10,000, and imagine speaking more zero, goes from 10,000 to 100,000 to trillion, to Brazilian. Brazilian is actually nothing. That I know of, but there are a lot of Brazilians, as far as I understand. Yes? But are we sure that 8 is coming from the right? That y is approaching 8 from the right? Yeah, and if it were approaching from the left, same thing would happen, except divided by a tiny negative number. So in that case, the answer would be negative infinity. Yeah? Okay. Now let's go back to this one. And Nico, thank you for starting us off with this. The bottom is, I'm going to talk about this in a couple of different ways. Which one of these factors do you think has got to go? This is a culprit, isn't it? So we're hoping that the top will also have a factor of x minus 2, but let's see, do we even have a 0 over 0 case? Do we have that? Okay, so since we have 0 over 0, let's do a little bit of factoring. How can we check to see if x minus 2 is a factor of that numerator? Did you already do this synthetic division? I'll give you a moment to do that. Or would you rather do long division?
Oh.
You're definitely crazy if you'd rather do long division, which is fine. It's not judgment. Did you get that nice 0? Was it satisfying? It is so satisfying
It's tough.
if you know what's good. Nico, can you tell us the other factor, please? Do we agree? Nice. So our culprit, we say adios to. And now can we plug in a 2? I believe we can. And you could always plug it in. The question is, are you going to get a number? 4 plus 10 minus 2 over 2 times 4. Did I do my addition and multiplication correctly so far? Bless you. Never understand why people would leave an answer like that unless they want me to have fun, which I appreciate, but I do need you to finish the problems that you do. Any questions? I get pretty excited when I do synthetic division too. I'm not gonna, and I sneeze because of it sometimes. So I just want to say one more thing about the top. Notice when you plug in the 2 for the top, you get a 0. And so once we know that that 2 is a 0, does that make sense? You can go immediately to synthetic division by just putting that 2 in the bottom. So not only was there a hint at the bottom that 2 was the culprit, it told us directly, hey, 2's a 0. Factor that factor out. Use it. Use that information. A lot of good information there. And speaking of good information, let's go to the other one that we were talking about. Thank you. This to you. Did you plug it in directly? Or did you find some other way to find f of negative 4? Can you show me what you got? Okay, I'm seeing negative 2's, is that right? Okay, I'm going to check by using synthetic substitution. Did I write these correctly? Okay. So negative 24, is that right? 4, 3, negative 12. So this is negative 1. What? Did I do something wrong? Okay, that's what you got. Okay, cool. Kimmy, you asked a really good question last time. I didn't give a good answer. Why does this work? I think it's important for us to know. I think if it's for a student in advanced pre-calculus, it's a fair question. So thank you for asking. So let's take another look at this. And straight off, I think you probably agree that the very first term is annoying to plug in a negative 4. Do you agree with that? So what they did is, or someone long ago, someone quite intelligent, looked at these and said, why should I plug in negative 4 to both of these when I could just factor out a common factor there, can't I? 6x plus 25. I'm just going to take that and factor out. I'm just going to factor out an x, though. And I'm just going to do some crazy stuff here. I take all of this and factor out an x plus 11. This is called nested factoring. Am I at 6x to the fourth right now? Does it say 6x to the fourth? Like if you were to multiply this out, do you see you get 6x to the fourth? And then a minus 6. And perhaps you could work through to see it's like exactly the same thing, isn't it? If you were to distribute it out. The 7 is in here. In fact, let me make that color coded. Right, 7 is with these parentheses, set of parentheses. This one is with the 11. And then the last one, I'll make that one red. Now let's see what would happen if we plugged in 4. The first thing would happen is we take the 6, multiply it by -4, and add 25. Is that what happened here? So here we get 1, isn't it?
Yeah.
And what do we do with that one? Multiply it by -4 and add 7.
Wow.
And what do we do with that? We multiply by -4
I don't
and
know.
add 11. And then multiply by -4 and subtract this. So that's where it comes from directly from this nested factoring, which I think is pretty cool. Like whoever came up with that, off the charts. They used to call that big brain, I believe. So thank you for asking. Let's do today's lesson, shall we? I believe there's no limit to how much fun we're going to have today. Get it? You get extra credit. Thank you. Thank you. Those of you who snickered. Thank you. You're very kind. I'll be here all week. Oh, that might have been it. That's yeah. Thank you. What's that?
Generational joke.
Generational joke. I don't know. That's it. I mean, they're all great. It's hard to choose a favorite. I just feel bad for y'all. Okay. One-sided limits. We already talked about this. You brought it up, right? We talked about this months and months ago. You can take, if you're going to a constant, you either can go from the left or from the right. So I think you already know. Does this statement here make sense to you? Whoa, look at that bold red. You don't have to mark that in yours, but does that make sense? Like reading math-wise. Right, the limit only exists if it's the same thing from the left and from the right. It looks like this. Right, 2 fingers pointing at each other. They have to go to the same place. That's when the limit exists without that plus or with the minus. So I'm going to give you a moment to take what you know about limits to find these. Yeah, it's definitely neighbor. They got the same. If you're in your neighborhood not sure, maybe discuss with people behind you, make sure all three answers are the same.
Yeah, but it's not. It's accident, just yeah. Unless it's this week, I'm just leaving. Zero.
Instead of that, how do you do it? I just, that's, you know, it's too left. That's what.
Yeah, check 1, 2. Oh, there we go. Okay. Hey guys at home. So I left it for a minute. Okay, so yeah, so we're not going to plug in 1.999. We're going to know that visually speaking, we're approaching a shape called a hole, but it's approaching that hole. Yes. And if we plug into, we get what's 4 minus 1, 3. Okay. I think visually speaking, it would look something like this. Did you actually graph it? Did you do something like this? It's fine if you graphed it. I don't judge. Okay, yeah, 2 from the left. You can see it's going to 3. 2 from the right. At this point, we're going to look at which part of the function? The bottom, because that's where x is greater than 2. So I think for this one, it would look something like, I would have something here, here, and I think it starts here with this one and then goes up like this. So approaching 2 from the right, you can see that that's equal to 0. That limit is equal to 0. Does it actually get to 0? It does not. Okay, now when x is approaching 2, do we agree that the answer is a number? What is the answer here? 3 letters. Does not exist. Remember, for it to exist at a certain point, what has to be true? Has to go to the same place. So I think some of you were answering a different question. If your answer was 1 there, that's just a correct answer to a different question. What would that question have been? Yeah, if it's the question of what's f of 1, then the answer is definitely, sorry, f of 2. F of 2, then the answer would be 1. And how would that be represented graphically? F of 2, it would be a point right there. Okay, so that's a whole lot of information there. Let's see where we're going. Continuity. Have you heard me say that word accidentally? Maybe I tried not to because we didn't actually talk about it formally. But today I feel a degree of freedom emerging. I could use this word after I talk about the definition. Informally, it means you could draw the function without removing your pencil from the paper, which makes sense given your understanding of the word continuity and your mastery of the language. But as a mathematician, you have to complicate things a little bit, so I'm gonna look for 3 criteria for a function to be continuous at a value of x, basically x equals a in this case. 1, the limit as x approaches a of our function exists. Step 2, f of a exists. And 3, they are equal. Now, I don't mean they have equal rights. I mean, literally, limit as x approaches a of f of x is literally equal to f of a. And I'll go over what this means with your intuitive sense of continuity. So we can make sure that we're getting everything in order. Take a look at this graph. It's asking you to provide the x coordinates where the graph is discontinuous, which is one way of saying not continuous. And once you've analyzed it, please show me how many places there are where it's discontinuous. Just from your understanding. Discontinuities. At x equals, how many are there? How many? Let me see. I'm seeing, take a look around with your fingers up. Make sure you get a consensus with one another. It should all be the same. There's only one answer.
Oh, can I get four, right?
Okay, show me how many you've come to consensus of. Let's see. Oh, well, let's just go from left to right. The first one happens when x equals -2, right? There's no way you could draw it from left to right without lifting your pencil with that. And don't say like, well, if you fold your paper like this, we're not talking about that. Put a hole in space-time continue. No, okay. X equals -2. That's the first one. The next one is, of course, at x equals -1. Correct. The next one is at x equals 1. Okay. The next one is at 2. Or are there 2 things happening there? They're going to be one thing happening at a particular value of x. So this is a little bit different flavor than the rest. At x equals 2, there's like a hole up here. Like there's the hole, and on that same value of x is like it dropped. It's over there. It's the same value of x. It's definitely not continuous. Now, how big is that hole? Yeah, how big is that hole? Yeah, how big is 1 point? Yeah, how big is 1 point? It's like one number like as big as a 2. No, that's not what you mean. You know the size of a point? It is an infinitesimal. Infinitesimal. It actually takes no time. It was one of your undefined terms in geometry. Do you remember hearing about those undefined terms? Points, lines, and planes. Like they're all infinitely small. Yes. They're holes. Yes. So even though it's infinitesimal, I don't want you to think, well, if it comes down to drawing a picture of this, I could actually just kind of jump over that hole because who would notice if it's infinitely small? That's the problem with thinking of it only as I can draw it. Yes, there are 2 different kinds of continuities. We're gonna get all the different possibilities that you had to be concerned about. Great question. Okay, so here we have the same graph. You notice this guy. Um, there there are different types of discontinuities. I think you could probably guess which are jump, infinite, and removable. Let's start with jump. Well, which one do you think is jump? X equals what? X equals -2 is a different one of these. Uh, X equals -1 is a jump continuity. And why is it? Because the limit as x approaches -1, what should I say about this limit? Does not exist, right? It's doing this. It's a mismatch. The limit just it violates the very first rule of continuity. It just the first rule is the limit must exist. Okay, it fails at D and E. I leave, yes. Oh, good question. Let's go to 2. It seems like a quick jump and then a like jump back. It seems like that. It's not that. So if it's not jump, then this would be considered removable. Good question. Yeah, it exactly satisfies 1 and 2, but not 3. So this has limit as x approaches 2 of f of x, right? That exists. And there is an f of 2 that exists. So it passes the first 2 portions of the definition, but these 2 are not equal to each other. And that just is how you justify this with limits. Good question. Thanks for asking. Okay, which leaves 2 more. What do you think this one is? Infinite discontinuity. And the way to justify that, well, you're going to have to use the symbol for infinity. How do you think you're going to use this? By saying the limit as x approaches -2. Now you have a choice either from the left or the right. Doesn't matter what you say. I'm going to say from the right just because I'm left-handed. That this is equal to infinity. Okay, there we go. So there's our infinity, either positive or negative. That's enough to justify it. Oh, excuse me. It is -infinity. Thank you. I should have from the left because I'm left-handed and positive. Yeah, either side is fine. Oh, from the right is -infinity. Which leaves us one more. This one. That is removable. And algebraically, I hope that makes sense with what we were doing today. In the problem part of the warm-up. When you remove that, when you cancel out those factors, that's removing that discontinuity. So for this one, it's just the limit exists, limit as x approaches 1 exists. But this does not equal f of 1. And really what's going on here is this does not exist, or 1 is out of the domain. But there's a problem with that equal statement. It just can't be equal because there's nothing there. So discontinuous there. But how about here at x equals 3? Is it continuous there? Absolutely. You see it's going to the place and there's a point there. So the function is continuous everywhere except those 4 places. The others you're not going to have to justify, but that's how it would be done. Suppose that limit exists and it's equal to the value of the function at that value of x. Okay, so that has been a lot of information so far. It is now 12:36. We will resume at 12:40. Go ahead and finish up the conversation. Okay, this is the last example I'm going to talk about today. And you're welcome. Here's some practice graphing rational functions.
Yeah, higher.
Yeah.
Oh, there's one of those positive. Okay. What's the bottom thing that one? Yeah, I mean, I think that. Yeah, like I already messed it up. Oh, yeah. Then you what? It goes all good. So I want. So it's, yeah, exactly. Exactly. Yeah. Well, down.
I'm gonna be calling a couple people to help me out.
No, I, that was very. No, that was.
My mind, that's why I did wrong. I look at it like that. Before it- You know, they go, you know, they go first draft job.
It's over. It comes to the turn. So we're like.
You're right. So better than what you're
This was either one.
Yeah.
And I don't have to work on it. I need that. I was like, are you there? I think it was. But you did have to take that. It's walking. All for David.
Wait, what happened? Oh, no,
Yeah, we were all traded for David. Oh, we are. They definitely wanted to trade for him. When you throw in 100, but you can't.
Maybe we had to, that's gonna be me right now. Yeah, wow.
He's good. It's a business. Can't be very sensitive anymore. It's
About ready?
Good.
You ready?
Yeah.
Okay. Oh, you can only say that because you've been called already. I see how it is. I see. Yeah, call for Mr. Lieberman. We're ready. Okay, I'll give you 10 seconds to finish up whatever idea you're working on. Okay, Lydia. It's not you. I'm sorry.
It's okay, it's okay.
I'm sorry. I love to mess with Lydia. So much fun. There it is. You're in the mess with Lydia club too. It's fun. No, actually, Lydia, I'm sorry. It's Zach. Zach. Zach, I like that proposal yesterday. Okay, by the way. That was interesting. Yeah, I've never seen that. Unique. Okay, so what'd you do here? Where'd you start?
But, there was a virtual officer that I wanted one, so I only did one.
Okay, and I'm just gonna put this on the right side. Oh, it's on. It is on first. Thank you. Do you agree that this is a good place to start? And you knew that the horizontal asymptote was 0 because. Was it frozen still? Oh, I thought it unfrozen. Thank you. Because what?
The higher power.
Exactly. Good. Yeah. Anytime it's bottom heavy, it's going to be white and 0. Okay. And do you want to keep going? You want to tell us what you did from there? You started with this?
Yeah.
How did you know it's up there?
I that point.
Plugged in a point. Okay. Fair. So let's say it's up here. And then? Okay. Well, we have to do something on the other side, right?
Yeah.
So, any suggestions? What can we do with the other side? Hey, Kimmy? Oh, before we get there, I want to go in this other side, like the little sliver in between. And we have to do something in there because we know it's not defined at x equals 1. Eileen, you have a suggestion? So when you plug in 2, you're finding the what? Sorry, when you plug in 0, you're finding the y-intercept. So when you plug that in, you get -2, you said? Okay, and then from there. And how do you know it's going down? Okay, you could do that, but 0.1. Okay, good. Any other tips? How can we know that it's going down there? Yeah, Levi?
Yeah. I think there's one is. Okay, to do, but I think that-
Okay, so if it's up on this side, then it has to be the other side. Remember that from how it's like up on both sides if it's even to be nice. Any other way? Let's say we didn't have this yet. Let's say we didn't put in a point. Is it possible that it could look like this? Why? But as the horizontal asymptote is when x gets to infinity. That one's, it could be crossing for small values of x. But there is another big problem here. Yeah, I made an x-intercept. Is there an x-intercept? Well, there is, but it would be on the other side. So we're not going to see it, which means it has to be over here. And if you were to continue it, it would kind of come up through that -2, wouldn't it? It'd come up and then maybe come back to that asymptote, that horizontal asymptote. But we don't have to worry about that. So it's definitely got to go down. And since it's down on that left side, we know that the other side is automatically going to be from above. So you don't have to plug in anything. I find this much more pleasant when you're not plugging in particular values. Although there's nothing wrong with it, and sometimes it is necessary. Zach, thank you for your help with this. I need some more help. Like post. Lydia, it's not you. But look in the other corner. We have Rhea. Oh, magic. Yeah, let's finish. Well, the same function, but the other part of it. Yeah. Okay. Ooh, are we good with that? Okay. -1, 4. Any questions about that? Keep on going. You're doing great. Okay, so maybe right there-ish. Okay. So you plugged in a -1? Maybe there's a point there. What else can we do without specific points? Do we agree that x-intercept is -4? Okay. Because there's this, of course. So that's not helpful. So we can kind of imagine it, and it's already there already, so that's okay. Okay, so I want one more thing without plugging in like non-zero values. In other words, let's plug in 0. Let's plug in 0. So we could find what would have been the y-intercept. Now, if your y-intercepts were up here, then you probably did something wrong. Does that make sense with these 3 points? And I should make that. There's probably something wrong. So it's not lining up. There is one more bit of information I think I may have put you off. There's something that's important, but with this function compared to this function. Are we good with that, everybody? Yeah, it has a horizontal asymptote of 1. Those asymptotes are really essential for building a good grid. So what happens when you plug in the 0? You get -4. I like plugging in 0. I don't like plugging in other numbers, although I can. 0 is a really pleasant number to plug in. Is this all working out okay? Is it lining up kind of in the right direction? Yeah, it's really pretty in fact. So I could go ahead and make my branch here. I'll respect the hole. How big is that hole? Indefinitesimal. Nice and set. Okay, so we've sketched it, and Rhea, thank you for your help. And Zaki too. Identify all discontinuities as removable, finite, in other words, jump or infinite. Justify your answers using limitation statements. Find the equations of all vertical and horizontal asymptotes. Okay, I'll give you a moment to discuss this.
Yeah.
Running a little bit low on time, so let's discuss. Going from left to right, the first discontinuity happens when x equals -3. This is called what kind of a discontinuity? Removable, because the limit as x approaches -3. Because this exists, but not equal to f of -3. That's a removable discontinuity, excuse me. Right, it says to justify using limit statements. So it's not enough to just say that f of -3 doesn't exist. You could say this does not exist, but the fact is that they're just not equal to each other. Okay, the next one happens when x is equal to 0. This discontinuity is called jump. And we would define this as, or the problem is that the limit as x approaches 0 does not exist. Here we go. And how many more do we have? One more at x equals 1. This is infinite. And to justify this, we would say that the limit as x approaches 1, either from the left or from the right. I didn't do left this time for equal measure. Is equal to, in this case, negative. If you have equal sums of infinity, that is good for justification. Ladies and gentlemen, that was a big lesson today. You can pat yourselves on the back for a job well done. Have a fantastic weekend. I look forward to seeing you on Tuesday. All of you, happy, healthy. Thank you, James.